Hello, everybody. We're about to start. Let's wait for 10 more seconds because I see we're already 1 minute late. And then we can start with the presentation. All right, let's go for it. It's lunchtime here in Belgium, so let's don't wait too long. Welcome to our JobRunner V8 launch webinar. Let's quickly, I promise there won't be too many slides, so there will be a lot of live coding. Who am I? You probably all know me as the founder of JobRunner, 20 years in IT. And I am a strong believer in green software. I hope we can do some stuff here in this regard, especially with all the large language models and the AI needing a lot of energy. We see a lot of Java enterprises now also using AI thanks to Spring AI and LangChain4j. And we hope that we can help make all of this a little bit greener. So first of all, this is an interactive webinar. We'll pause for questions after each section and at the end of the webinar. Do not hesitate to reach out or to write a comment if you have a question. And then I want to start with a big thank you, because V8 wouldn't be what it is without contributions from the open source community. And one big contribution was done by Jacob Hofer, who has the nickname @Simulatan on GitHub, and he added really well Kotlin X support in JobRunner. Then Devashish Tanecha is also a contributor who helped us with the async job annotation. And then a really big contribution was done by Mindwave and Georgios Skourzitsis. Mindwave is a Belgian company, and they really helped us with everything related to the carbon-aware job scheduling. And of course, JobRunner would definitely not be what it is without the team that's backing me up. That's Walter, Ismaila, Donata, and Nicholas. And then another big thanks to all our pro customers and our open source users. So for those people that don't know yet what JobRunner is, a really small introduction. Well, it's an open source library. You just add one dependency and you can start with distributed background job processing. And we, of course, integrate with the best, being Spring Boot, Quarkus, and Micronaut, and all the different SQL and NoSQL databases out there. By default, it comes with a dashboard. There is metrics, and if your job for some reason fails or one of your Kubernetes pods goes down, well, JobRunner will notice and automatically fail over on another node. What do we support? Well, we support enqueuing jobs, which are fire and forget jobs, scheduled jobs, recurring jobs, and all of these jobs are in fact distributed jobs. And last but not least, we also have JobRunner Pro, which allows me to not only feed my kids these days, but also my awesome team, where we have features like priority queues for critical workloads, dynamic queues, which we will show during the demo, and a lot of other nice features. So what are we going to show today? Well, we start with the feature that we're most proud of, which is carbon-aware job processing. Then for our pro customers, I will demo the multi-cluster dashboard. Then for OSS and pro customers, we have done some improvements to recurring jobs. Then we will talk about pausing dynamic queues, which is again a feature in JobRunner Pro. Then I will show you the Kotlin JSON mapper, how you can use it. This is the contribution done by Jacob. Then we'll talk about runtime configuration for rate limiters, which is Pro. Then one really nice feature that we added both in open source and Pro is really an improvement on how to handle idempotence for long-running jobs. We'll do some live coding for that. We also improved the dashboard with a new notification center. And Josh Long gave us a tip related to how to make the code a little bit developer friendly, and this is the async job that was also contributed. And then of course there is a lot of time to ask questions. And then why are we introducing this carbon aware job scheduling? Well, the summer of 2024 was the hottest on record globally for Europe. And I just read this morning that also June was the hottest month of ever. And if you look at the graphs, we see that we are already past 1.5 degrees here in Europe. And just yesterday, thousands of people had to stay home in Spain because of forest fire rages. And yeah, a lot of these things are related to global warming. I don't like to call it global warming, it's more the global catastrophe. But I prefer to be hopeful and to change something about it, and that's why we started working on the carbon aware job processing feature. And that's the one I want to demo to start with. So we'll now switch over to IntelliJ. And we're going to start with a really simple example. So this is just plain JobRunner. So the carbon aware job processing feature is both available in JobRunner open source and Pro. And what do we do here? Well, we have the job scheduler configured using an in-memory storage provider. We use the dashboard, and then as you may know from the past, we could just schedule a job at a certain time like this. So if I quickly run this, then I think it should be already up and running. And if I go to localhost 8000, oops, this was not meant to be. We have the jobs here, and it's scheduled for today at 5 p.m. But what if we want to do this with carbon aware job processing? Well, that's really easy. We have this existing schedule method, and the only thing I'm going to change is quickly cut out this part and just start typing carbon aware dot, and then I have some options: add, between, before. In this case, I'm going to use add, and I paste in my existing timestamp that when I wanted to schedule the job. But I also give it a range, an extra margin where JobRunner can run this carbon aware job. So this margin allows us to schedule the job at the right time. Sorry, so this is duration dot of hours 3. So meaning that this job will be scheduled carbon aware today at 5, but it may run up to 3 hours before and 3 hours after. So it's possible to run from 2 p.m. to 8 p.m. There's one thing that I still need to do, and that is to use the background job server, of course, and configure the carbon aware job processing. But because this is a new feature, this is disabled by default. So what I will do is using standard background job server configuration. And then we do add carbon aware job processing configuration. Just adding some imports. And there is one important thing that you need to provide there. That's the area code. And this is the area where your server is located and that we use to fetch the correct forecast for that area, the carbon intensity forecast. And since I'm located here in Belgium, I will use BE. And if I now start our JobRunner instance again, well, it's again running. And we will see a difference here. So the job here is scheduled again, but it has this new leaf. And this leaf means that the job is scheduled carbon aware in this case. And if we go have a look, then we see that there is an extra state that we introduced, which is job pending. And what happens? Well, let's say that you want to schedule a carbon aware job somewhere in a week from now. Well, in that case, we do not yet have any forecast, because typically the forecast is only provided 36 to 48 hours before. So the job will go into pending, and as soon as there is some forecast available, well, then JobRunner will schedule it at the best moment. And apparently for Belgium, this is 2 p.m. But we had feedback during our beta that, hey, I don't believe you. Why is it 2 p.m.? So, well, what we do now is we display the complete details inside the pending state when the best moment is, in fact, to run your job. And if you have a look, well, the bottom bar is all the different periods that we got from the ENSOE, which is the European Network Grid, who provides us the forecast by hour. And there we see all the different, depending if it's greener, then the better it is for carbon. The least amount of carbon will be generated. The redder it is, the worse it is. What you also see is this other red line above the other line, and the red line is in fact the line where we cannot schedule the job. And remember that I said, the job can only be scheduled at 5 p.m., but I give it 2 hours earlier, 3 hours earlier, 3 hours later. Well, this gives us the range from 2 p.m. until 8 p.m. And that's what the top line, in fact, represents. Of course, this can also be done for recurring jobs. And this was, to be honest, quite a challenge, especially in JobRunner Pro, where we want to guarantee a really, really high throughput of recurring jobs, because there some companies, some of our customers are running more than 1,000 recurring jobs. And we wanted to guarantee the good throughput. That's why we, in fact, created 3 different implementations of this, and only the 4th implementation was deemed good enough. So I will again do the same thing, schedule, but this time I will schedule the job recurrently. And here we do exactly the same approach, carbon aware, and now we can say cron. And this can still be your existing schedule, so let's say daily at 8 p.m. for example. But also here again, we need to provide a margin before and after. So what I do, duration of hours 2. And then I can do again do work that takes a lot of CPU, my input. If we start this now, then we will see exactly the same here in the recurring jobs. So this is a recurring job. It's scheduled again at 8 p.m. and we see that it is, again, it has the green leaf, meaning that it's carbon aware. And the big change that's both visible in JobRunner Open Source and JobRunner Pro, what we needed to change is that instead of scheduling the jobs from recurring jobs right before they needed to launch, like in V7, well, we now schedule them ahead of time, because we need to know when the best moment is to schedule them carbon aware. So what you will see now, that it's here scheduled again. And yeah, it's of course 2 times the same. And one of these two is from the recurring job. This one is from the recurring job because we mentioned it here. And also here we see that there is now a different graph, a carbon intensity graph. Again, 6 o'clock is the best moment for the 4 hours that we allowed the job to run. So this new carbon schedule API allows us, or allows you, to schedule jobs still making sure that your business rules apply. So the exact hours where you want to run it will be adhered to by JobRunner, but using that little bit of flexibility that you give using the margins, we can schedule the job at the best moment. There is one important thing that you need to do for this. Well, we for the moment, we only support Europe, because there it was easy to get some information. We're currently in discussion with Wattime, which would provide us with global coverage to support this carbon aware job processing. And that's why we have now a really simple API running at api.jobrunner.io, where your JobRunner instance will need to do a ping once a day. And what does it do? Well, it gets the forecast for the next day. So if you want to enable this feature, please make sure that you allow the firewall to do a ping to api.jobrunner.io, so that way that it can fetch the correct carbon intensity forecast. One extra feature that we're also looking into for our pro customers, and this is after having feedback from some of them who are testing this feature, is that they want to have like a combination of carbon aware but also cost aware, because some of them are running on AWS or Google Cloud or Azure, and their bills are getting quite expensive. And that's why we are currently working and seeing what's possible to implement something like this. AWS cost aware before today at time 20. And again, we could just pass a lambda as before. And then JobRunner would check using AWS spot prices whether it's perhaps cheaper to run the job in a different type at a different time. So this is something we're investigating currently and seeing whether this would be possible. So that is the first big feature that we wanted to introduce. I hope you all use this, that we can all together be part of the climate solution and to do something good about it. And let us know your feedback on this feature. We're really keen on finding out how you are using it. And if there are no questions about this, then I will move forward to the next feature. And I don't see any messages in the chat, so that's good. Then something special for our customers, and I really want, again, I hope everybody, also the open source users, I try to talk a little bit both about open source and pro, because they make possible that we continue to maintain the open source version. They really help us. And there is a question apparently. Okay. Just a second. We have a question about something. So the question is, how is it determined when carbon footprints will be the smallest? And it's a good question. So here in Europe, we have an organization which is called NSOE. And NSOE, I will quickly show my browser. I do not want to spend too much time also on this because we still have a lot to cover, but NSOE is the European government, like a little bit like European standard, where every European energy provider must register and provide forecasts for the next 36 hours. And this is where we get the data from. We then transform it that it's really consumable for JobRunner. And by having our own API, in fact, we can also plug in other providers because there is definitely no standard in this regard yet. So the US has other providers, and that's why we needed to have our middle API in between. But I hope this answers the question. You can find more information here on this website. All right, so let's continue then. The next thing that I want to show for our pro customers is the multi-cluster dashboard. And this is also a really cool feature, I think. Some of our customers are running over 1,000 JobRunner instances. I would have, if you would have asked me that a couple of years ago, I would not have believed it. But then having an overview of all those different jobs, how are they doing, it's becoming really difficult. And on top of that, sometimes you want to really pinpoint from your Datadog instance to directly go to a certain job. You can enter links in the data in your logs so that they're clickable in Datadog, so that you instantly open the dashboard. But with all those different instances, it was quite a challenge for them. And that's why we have now the multi-dashboard. And I am going to start it here. So what we do is we start multiple different JobRunner instances. And an instance can be also having multiple servers. So we start, in fact, multiple clusters. And if we then go to the dashboard again, we have something new. So here you can see all the different clusters. For this example, I added 3 clusters, and it gives you an overview of all your different, how all your different jobs are doing. Of course, you can click down, and again, each recurring job or job will also have its own cluster info, like we can see the different cluster names here. And the same happens also here, where the columns are configurable, and we can make sure that this is all visible. And this is also really made with ease of use again. What does that mean? Well, there are different ways to configure this. You can have the multi-dashboard running, and it will auto-discover all your other JobRunner instances by using, because they announce themselves at the dashboard. And it's also really reliable, because if I would kill a certain dashboard, which I can do here now in my instance here. Well, as soon as it will go down, the multi-cluster will detect it after a certain timeout, and then we will see that the cluster here will be not marked online anymore, but offline. On top of that, we can also select to view only the clusters, the jobs of one cluster. Ooh, this is not supposed to happen. Let me Control V. Let me see what was. Yeah, sorry for that. It's perhaps maybe related because cluster 9001 was the one responsible for propagating the license to the other cluster. Anyway, yeah. And what we see now, the cluster of 9001 was is down now, and hence we can see it here. And in the dashboard, I now only see the jobs of the first cluster. Of course, I can select these two clusters or even the third cluster, but that one will not give me any jobs because we noticed that it's down for the moment. So that's that. Now, let's continue the story. I'm quickly going to turn this down. That way I don't have any containers or ports blocking anymore. And let's continue with the rest. So this is the recurring jobs improvement if you're using Spring Boot, Quarkus, or Micronaut. I have a really simple Spring Boot application here. And in the past, when you had recurring jobs that were using the @recurring annotation, this all works nice. But the moment that you refactored, that you cleaned up your code, well, then that recurring job was still there. But the code wasn't there anymore. And both in JobRunner open source and Pro, we now clean this up for you. So that way you don't have to worry about the cleanup in that regard anymore, easing your deployment. So let's say that I have a recurring job here, my recurring job. And let's start the Spring Boot application. And voila, it's there. And if I then go again to the dashboard, and this will not be a multi-cluster dashboard now, but if we go to the recurring jobs, of course, we see our recurring job here. If for some reason then I decide that I want to pause this or I don't want to run this, we do a redeploy of our code. So I comment this code out for the moment. We start again, we redeploy the application. Well, here we already mentioned it in the logs. Deleted recurring job as it was created by @recurring annotation, but it is not annotated by the @recurring annotation anymore. So, if I go to the dashboard again, we see that the recurring job is gone. It's a small quality of life improvement, but it's feedback that we often received that after a redeploy and some refactoring, that it was a pain to delete all the recurring jobs. Well, yeah, that's now solved for you. All right, let's go to the next feature that we want to introduce, and that is a Pro feature again, where we can pass dynamic queues now and have colored labels. So I prepared some stuff here. I have a job API. And dynamic queues is a feature that is really useful when you have a multi-tenant application and you want to prevent one of your tenants to create 1 million millions of jobs, and then all your other tenants have to wait until there's 1 million jobs are done. So that's one feature that was requested by some of our clients, and hence we introduced the dynamic queues. What changed in JobRunner V8? Well, we made it a lot better performance-wise, and we also allow to pass these dynamic queues, which again eases deployment sometimes of new functionality on their side. So how do we do this? Well, let me private job scheduler job scheduler. We have the job scheduler in this case that we need. I'm going to create a constructor for this, the job scheduler, and then we are going to use, I also need the tenant service, private tenant service, constructor parameter. And then we want to do enqueue a job, for example. And in this case, I want to use the tenant service. And we have a long-running method for the tenant up like this. If we start our Spring Boot application now, perhaps a small introductory on how you configure the multi-tenants. Well, in this case, we have the dynamic queues, and the tenants are, in this case, mapped to dynamic queues using the round-robin strategy. And how do we determine it? Well, by using a label prefix. And the label prefix determines that the label prefix with tenant will be that dynamic, using that dynamic queue in this case. So we go back, because I think I made a small mistake, because this is not using an annotation. We could use the annotation here, but what I want to do, in fact, is I want to do create using the job builder. And then how do we use that? Well, job builder dot a job with name job for tenant, like that, with labels, and then I can just say tenant plus tenant. And I can also add other labels, for example, in this case, warn, false, any labels that we want. And then with details, and then we can use our existing method here. And I think I'm missing an exclamation mark like this. So the important part is that we determine the dynamic queue based on the labels here. So I'm now going to start the application again. And I need to make sure that I don't go over time. So what I'm going to do, I'm going to copy this part here and explain it to you what I'm doing instead of all the live coding. So we have a variable here in the IntelliJ HTTP client, being tenants, and then we create some job for the different, for each tenant we create a job. And it's all done. And if I now go to my dashboard, we already see this top tenants here. And now automatically the JobRunner sees, this is dynamic use. So what did it do? Well, it's now using the round-robin strategy for each of those tenants. So even if tenant A would create 1 million jobs, tenant B would have also equal amount of processing power. And the feature that we also introduced here is the possibility to pause the dynamic queue processing. So now all job processing will still happen for the tenant A, tenant C, D, E, but not for tenant B. And this is also possible using an easy-to-use API, which is, let me show you, using the dynamic queue manager. So let me uncomment that. We can add the dynamic queue manager again, which is a Spring Boot bean, or also available for Quarkus and Micronaut. And this dynamic queue manager allows us to pause a dynamic queue or resume a dynamic queue. And what I do here in the post mapping, well, we say dynamic queue, the tenant, and then a request parameter, which has of name pause and has default value false. if we now go back to this one, let's me double check. So it's dynamic queue tenant post. I need to create a new one, pause dynamic queue, and then we do HTTP localhost dynamic queue, and then I say, for example, tenant E, and I add pause is true. Run, it's a 200, so it should be okay. And then the next poll interval, the background job server will notice, hey, this dynamic queue is paused, and it will stop processing the jobs. So normally soon we should see this one pausing. We can wait for it. I tested it before. It takes a little bit of time. It can take up to 15 to 20 seconds because of the poll interval. So yeah, but that's how to pause dynamic queues. All right, then a really important one, which we made it simpler to make jobs re-entrant and idempotent. And I don't know whether you know this from our documentation on our website, but one of the best practices when you're using JobRunner is, there are a couple of them, but a big one is make your job arguments as small as possible because they are as saved as JSON inside the database. But the other really big one is make sure your jobs are idempotent or support re-entrancy. Because if for some reason your job fails and it will start retrying to retry everything, yeah, then you may be doing unnecessary work, or in case you're a bank, do the same payment twice, which is definitely not something that you want to do. There are a lot of questions suddenly. Is it okay if I answer those questions after let me answer the question about the dynamic queue quickly, and the other about Helidon I will answer after the session. So what happens to concurrently running jobs for dynamic queue when it's paused? Will they finish processing or will they be killed? Well, they will finish processing. We do not kill the jobs yet. It's an outstanding feature request which was created after that after the beta test. But the idea would be that you would also have an option to kill the job later on. But for now, we wait until it finishes processing, and then what we do is, in fact, we don't onboard any new jobs from that dynamic queue. So the existing jobs will continue finishing. Okay, and then yeah, the cluster, I will get back to that later on. So idempotence, and this is again in open source and in open source and JobRunner Pro. So of course we had to do something with AI, and we're not doing it really, but imagine you're summarizing some documents, then you send those documents to Olama for RAG embeddings and ingestions, and then finally you send an email to the sales department. But it can be really a lot other stuff, like any step that you only want to do once when your job fails. Well, this is then what you will need to use. And how to do that? Because if this job would now retry, well, even if the summarized documents or the send documents to Olama part was already done, well, by default, JobRunner would run them again, because currently this job is not idempotent. How to solve that? Well, we added a new utility method on the job context, and this part is not necessary. IntelliJ autocomplete a little bit too much. And the job context gives you extra information about your job, but we can now do some really nice thing here. So job context, run step once, and then we give it a name. So you give your step a name, and in this case I will do summarize documents. And what does it expect as a second parameter? Well, runnable. So what we can do is this.summarize documents, and then we can do exactly the same thing for this part, and we do it once more to send the email to the sales department. This part we can now drop. And I'm going to make this really interesting. What I'm going to do is I'm going to pass the job context to here. And the job context also has information on how many retries and stuff are happening. So what I will do now is job context dot current retry is 0. If then I throw a new runtime exception, I want to see it fail. So what will happen? Well, because there is no retry, JobRunner will throw we will now throw an exception here. JobRunner will catch it, will automatically retry the job. But what we will see is that this part and the start summarizing documents will not be done anymore, because in fact we already have done it, and the step will only be run once. Of course, I need to pass the job context here also, so let's do it like this in that case, job context. And last but not least, we need to create the API for this. So I'm going to also use the AI service now, private AI service. We add a constructor parameter, and then what we do is job scheduler.enqueue AI service.mylong, and then we pass in the folder. And now, of course, we also need to pass in the job context. Well, how can you do that? Well, really easy. On job context, there is a field called job context.null, and this, by using that one, we know that you want to have it injected automatically by JobRunner when the job actually starts. So we do it like this. I'm going to stop my server, start it again. And then if we go to test.http, we do again, in this case, start AI service. And then it's not this, but AI training folder, my folder. It's just some arbitrary input. I launch it, that's running. Let's go to the dashboard jobs. Where is it? Processing. It's processing. So we now have, of course, also light updates. And what we see, well, we start summarizing the documents. We finished summarizing the documents. And now, we wait until it's processing again, which just started processing again. And so the start summarizing documents and finished summarizing documents part will not be done anymore, because we do this we do this idempotent. And again, indeed, we see that it skipped the summarization part, so we start sending the documents to Olama, and then we finished it, and then the rest goes fine. So again, a really important feature, and again, quality of life improvement that helps you making jobs more resilient in case of failures, and when you have big jobs that do a lot of stuff. All right, stop. And what else do we want to show? The feature for our Kotlin friends, thanks to Jacob, who was really helpful on, who in fact did the complete integration of Kotlin serialization inside JobRunner. And again, I want to thank him for that. So let's have a look. Example, Spring Kotlin. I have here again a simple controller. These examples, we will also publish them all on our examples repo on GitHub. But if I run this application, I must make sure that my other application is down. Is it stopped? Okay, perfect. So if I run this, well, we can now use Kotlin serialization, and JobRunner will automatically detect that if Kotlin X serialization is on the class part again, we will switch to Kotlin X serialization. And then what do we do? Well, we have here, for example, a simple job using a service and an object, and we can pass in a request parameter. And what we then do is we pass this object again to another service, which is using the person Kotlin data class, which is marked with serializable. If we run that one, we see, okay, the job was enqueued successfully. And if we go to the run part again, normally we should see some nice output as soon as the job is processed, and there it is. So thank you for implementing the Kotlin X serializer, Jacob and H20. So there is that. The Kotlin X serializer both works in JobRunner open source and JobRunner Pro. All right, let's continue the webinar. Another request that was requested to us from our customers was, we are using rate limiters. And sometimes you may want to adjust rate limiters at runtime. In the past, this was not possible, but now in JobRunner 8, we do allow this. And again, some live coding for that. So let's have a look. I have this rate limited service where we run some rate limited jobs, and again, something with AI, Olama. We train some Olama thing, and we want to rate limit on Olama. So this can be an external service, and this is configured in application.yaml. So what do we have? The jobs are rate limited using a concurrent job rate limiter, and you can have multiple ones. And for Olama, we currently only allow 2 concurrent jobs, which is not a lot, of course. If we go to the API, of course, we need to implement this again. So I will use the add also the private rate limited service, again add constructor parameter, and then job scheduler I need to, of course, create a lot of rate limited jobs, otherwise this will not be that useful. So we create 1,000 of let's do crazy 10,000 of rate limited jobs. We have a stream, so this could be IDs, for example. Now we do job scheduler dot enqueue. We pass our stream. So by the way, small performance tip: if you have a large collection of objects for which you want to create jobs, always use a stream, because that way JobRunner can batch really efficiently to the database in the best batch size to save all these jobs as fast as possible. And then I have an integer here, or the ID in this case, and I can do rate limited service dot run later rate limited job, pass in my input and ID. So that should be that. I am going to start our application again. But what I will also do already is change this and make it available. So we want to have, again, a private rate limiter manager, in this case, rate limiter manager. Again, let's add it as a constructor parameter. And then we want to save the rate limiter, and in this case, the concurrent job rate limiter by name and concurrency. So what will happen, I will update the rate limiter at runtime using the name, which will be Olama, and the new concurrency that we want to allow. So if I start this, it's running. We go again to the test.http. Voila, we create. Well, we created 10,000 rate limited jobs in this case. And let's see what is happening in JobRunner jobs. If I refresh this, pending. I did not expect this one. Did I do something wrong? Rate limited job. If anybody sees what I did wrong, please shout out. Okay. I created this in the wrong function. So stop. Start again. This is for later on, the last part. All right. Now let's create the 10,000 rate limited jobs again. There it is. This was already a little bit more realistic, 900 milliseconds to create 10,000 jobs. And if we now go to the pending page, we see there are a lot. There are 10,000. So the first thing what JobRunner does is it tries to determine the correct amount of jobs that can be processed at the same time. So once it has a baseline of how these rate limited jobs, how much time they take, then it will start enqueuing the correct amount so that other jobs are not being disturbed by it. And we see here my rate limited job for hello, they're being processed 2 at a time, my rate limited job. But now let's try to increase our performance a little bit. So here we now configure the rate limiters for Olama, and we increase the concurrency to 40. So bloop, we post this. And then again, if we wait for a poll interval, normally this the processing part should start go faster and faster. Processing, here we go. So we're now doing, we have updated the rate limiter at runtime so that we can process more jobs faster. And then the other thing that we still have, but I'm not going to talk about now, is that we also have better integration with Kubernetes for our pro customers, where we can now auto-scale in advance. Typically, Kubernetes uses CPU and request times to see whether it needs to scale up and down. But what if you have 1 million jobs that need to start being processed, for example, at 10 a.m. Well, using our integration with KEDA, what will happen now is that like a certain amount of time, which is configurable, of course, like 2 minutes before, we will notify your Kubernetes cluster, hey, using KEDA, hey, it's already time to scale up. So scale up to, for example, 10 pods. And then exactly your pods will already be available the moment that 10 million jobs at 10 o'clock will enqueue. And then as soon as all processing is done, it will. You also have the option to scale down automatically again. So again, something good for cost reduction for Pro customers. And that's about it. Right inside the time box, I quickly want to have a look at the chat also. To see whether there are any questions that I can still answer. Sorry. And one question that I see is, how do the clusters become aware of each other? Well, that's a good question, and I will try to show you. So if we go to the multi-cluster test, we have a single cluster, and what happens is, in fact, you configure your JobRunner instances or your clusters, in fact, with the multi-dashboard URL. And what they will do is they will announce themselves there, and this way the cluster knows, there is a new new dashboard available, a new JobRunner cluster processing jobs available, and it will then visualize them. There are multiple ways you can, and we also documented this really nice on our website, by the way. So documentation, let me check multi-cluster dashboard. So we are a big fan of the C4 diagram. So here you see the multi-dashboard, which is then forwarding all the calls to the different clusters. But you can have a much more complex setup. For example, if you don't want to use REST, we can also just go directly to the database, and so there is a whole way how you can configure this. But the easiest way that we validated with one of our customers is that the cluster just announces itself at the multi-dashboard server, and then that's how it processes things. Then other questions. What happens to currently? We answered that one. And then the other question, for auto scaling, can this be used with CloudWatch and Fargate? For the moment, we support CADA only, but we're definitely open to look at Fargate. You're not the first one to ask this question. I think we have the infrastructure part now ready. So we need to see. It's time. Time is difficult. And I just also remembered that I forgot to demo one small piece. So if you give me 2 more minutes, that is the async job annotation. Job API, create job using async job annotation. Well, and this was a feature request by Josh Long. JobScheduler.enqueue, although the API is rather easy, he says, it's still a little bit bloating my code. I want to have it even easier. And that's why you can now annotate your class with @async_job. And then you just have here a method run async job. And this is like the same paradigm as @async in Spring, where you say you have, by annotating a class or a method with @async, well, in that case, the code will be executed on a different thread. Well, it's exactly the same thing, but what we will do is we will create a job for it. So if we go here and I use the private async service, I add a constructor parameter for this, and then I do async service dot run async job input. We start again. I'm going to quickly, because there is a lot of the 10,000 jobs are still in there, so I'm going to restart my Docker container. If you launch this now, so you don't see any job scheduler anymore. It's just plain Java. You call your existing services like you would, but behind the scenes, we will use Spring RP proxies to detect this call, and instead of running it directly, we will create a background job for you. And this was also contributed. So yeah, really nice feature. I will quickly show it. So if I go to test.http, I'm going to use the backup. Thanks, Josh, for the ID. Test.http. Let's launch it. Whoop. And if I go to the dashboard, localhost 8000, we should normally have a job enqueued or processing. And this is done without any job scheduler or any reference to JobRunner inside your code. So if you want to have less bloat, this is a really nice way to do it. And then will the demo be accessible via GitHub repo? Yes, we will try to create two GitHub repos, one for our pro customers, which have access via our pro community, and then one where we showcase all the open source new features, which will also be available, of course, open source. So thank you for joining. I hope you enjoyed it. Feel free to reach out if you have any questions. Feel free to give feedback on carbon-aware job processing. And yeah, thanks for being part of this awesome community.